Welcome to Study Loop.
In this problem, we have two different electromagnetic waves. In part A, we have a radar signal with a frequency of 22.75 times 10 to the power of 9 hertz, which I should have written. And what we want to know is what is the wavelength corresponding to this frequency. So in general, with electromagnetic waves, the way to relate frequency and wavelength is to hold their product constant. So wavelength times frequency is equal to the speed of propagation, which for all electromagnetic waves is speed of light, c. So in part A, we want to isolate for wavelength. So let's rearrange this to be wavelength equals speed of light c divided by frequency. And we're given the frequency, and we know c, so we can just plug them in directly. We have our speed of light, 3 times 10 to the 8th meters per second, and our frequency is 22.75 times 10 to the power of 9 hertz. And if we plug this into our calculator, we'll find that the result is about 1.319 times 10 to the power of -2 meters. So that's the wavelength of our radar signal. And then on the other hand, in part B, we're given a wavelength of 0.2 nanometers of our microwave electromagnetic wave, and we want to know its frequency. So we can use this same equation and just rewrite it a little bit differently as frequency equals speed of light c divided by wavelength. So we know the wavelength, we know the speed of light. So putting it together, we have 3 times 10 to the power of 8 meters per second as our speed of light. And for our wavelength, we have 0.12 nanometers, which corresponds to 0.12 times 10 to the power of -9 meters. A nanometer is 10 to the power of -9 meters. So if we calculate this, we'll get a result of 2.5 times 10 to the power of 18 hertz for our frequency in part B.